Well, first of all, thanks for having me here. Really nice office. I think my first time in Iasi was in 2010 or 2011, still an old building. And it's interesting to see how this is evolving and how the company gets bigger. This is really great, so thanks for having me. I would like to begin the presentation with a quote. So when we were flying here, we were jokingly discussing how theory corresponds to practice, and this touched something inside me. So I found a quote, and it goes like this. Yeah. And the guys actually, nobody knows who really told this, but yeah, this is what happens. Yeah, you can see. Okay. So the thing is actually that there is always you need to find this balance about what you're going to talk about, what you're going to implement. So if you're reading or listening to somebody who is telling you these specific things, yeah, they might apply or might not apply to you. So this is really interesting to listen to. However, at the same time, if it's purely theoretical thing that you're listening, you also can't use it in practice. So I believe that the right balance between those two exists because you need some ideas that you can implement on any project you start. For example, if you're not working with .NET, looking how .NET is organized is really helpful because you can see how it's done also, well, not see, but how it's called, compare how it's done in Java and everything. But if you go a level higher, this is where you can apply it to everything. And this is what I'm going to talk about today. More a bit general, but things that you can apply really at your everyday work. Now, another quote before I start. If it's working, yes. Yeah, also the guy is known, so yeah, sometimes it's happened like this. So you find something out, and then yeah, you never know what's going. Now, what we will cover today. I think that these are 4 important ideas that you need to bring in your software development work, everyday work. Regardless, I'm working with monolithic applications, or I'm working with microservices. These are the same thing. I think, even not I think, I'm sure that you need to know about the life cycles of the features application, how they're working. The process of application delivery, very important stuff, especially if you go to microservices. The teams, what about the teams? And I'm a big fan of lean ideas. I'm going to share a bit of lean software development at the end. Okay, really shortly about me. I worked since 2004. I come from Ukraine. Then I was also from 2007 to 2010 living and working in Estonia, and I work as a system administrator at the shipbuilding plant. And the interesting part is that I saw the manufacturing there, and now, a lot of years later, I reflect to the things I saw on the floor that are happening, about how this is organized, and especially if you compare it to Lean, and how it goes with the software development, how we're doing the very same things, and now how we're doing the very same mistakes as the companies that are doing manufacturing has already learned from and developed. So yeah. In 2010 I returned to Ukraine and started working for Levi9. In 2011 I learned a thing called DevOps, and this is the thing, the idea that changed my career. So it was fascinating how actually can organize teams where development and operations can be working together, really. And since then, yeah, I've been working as system administrator, as DevOps engineer, as automation engineer. For some time, well, slight time I was doing QA work, I was a product owner. I've seen some of the aspects of the work. But the tragedy of this is I stopped calling myself DevOps engineer and I stopped trying to do anything with DevOps. Because on the market, in most cases, this is just how system administration is called. And the separation between development and operations is still there. It's just now, oh, it's not system administrators or operations engineer who is going to deploy applications. Just DevOps engineers now. What has changed? But yeah, the market is market, so I have to adapt to it. Okay, now let's start. So, the life cycles. In any project management book, you will see these 5 stages of any project. It starts with initiating, You need to understand what you're going to do, then plan how you're going to do it, then execute, and monitor and control, and these two go combined together, and then close. This is actually something that most people forget, but yeah, you need to close it. And if you think of this, this applies to all applications. They are needed by people, to product, to services. It's the very same thing. You initiate them, you create them, you do a lot of development and then here, and then you close them, but they're no longer needed. But if we're looking more detailed into the feature delivery, it goes like this. We're coming up with an idea, we're planning it, we're coding it, we're building it, testing, releasing, and operating. And for every idea, we need to go through these stages for each one of them. And this is what, to me, for quite some time was continuous delivery about. But actually, here in this diagram, misses one important thing. It misses feedback loop from production, like there. And this is what I think businesses need nowadays to create those loops. And it can look like a PDCA, loop, plan, do, check, act. When you first plan something, then you implement it, you check how it's going, and you react on this. You either continue working on the feature or stop doing something like this. Or what is called in lean startup or in enterprise, build, measure, learn cycle. It's the very same thing. You implement something as quickly as possible, trying it out with the real users. If it is needed by users, you continue developing this feature. If it's not needed, you stop in this. And this is what learn is about here. Learn is here. And yeah, this is actually, in a lot of cases, this is forgotten. And sometimes these ideas come to business people, yeah, we need to implement the feature. And then it is developed for half a year, sometimes a year in some projects. And then it's in the market, and then nobody needs this feature. And this is such a waste, this is such a shame, because so many people put effort into creating this. And if it's not needed by anyone, you better know it as soon as possible. And this is why I think IT and software development need to help business, because it is, I put the quality side here. We're living in what is called digital transformation era. We're consuming all the services, all the products through the digital way. And we are consuming brands and services, we see them as an integral part. So there was yesterday discussion about Wacom, about how if people are ordering something, and it's a company that delivers fucks up, people still think that it's a company where they bought the service from, or the product from. So even you need to control just everything, and to control the whole user experience. And we as a software development can help here. Really can help here, because business doesn't know what they need. How we can do it, and if we go to these loops, it's working, yes. So the main idea and the main requirement of business here is to build as soon as possible something. Just as rapidly as you can, and then measure it. And for that, I believe we need two main things. And especially for microservices, because then you're doing it at a huge scale. Because you need to build quality into the process, and you have a team that has shared responsibility. Let's have a look. So, first of all, data street. Everyone knows how it's working, right? It's development, testing, and acceptance to production. Here, nothing is ever working. Here, sometimes it's working. Here, well, some people find some strange bugs, and then it goes to production. I'm a huge, I actually think that this needs to stop. This thing doesn't provide any value anymore in development, and especially in microservices, especially for enterprise. And people try to aggregate some changes here, there, and this actually delays delivery of new code to production. And the code that is not delivered, it generates zero money, it produces no value. So this is how we need to think about every feature that is coded. And there is no detect here, just whatsoever. In most cases, when we're talking about this delivery and the processes, we are talking about this phase, these three main stages. And I have this, well, generally you will understand the idea of pipeline here, that on one side of it you are throwing the source code, On another side of it, you suddenly get a working application that is in production. It goes through all 3 stages and build something to do with the source code, everything that has to do with the source code. You're running on the build stage. And as a result of build stage, you are producing an artifact that has a version that must be tested. Must be tested, yes. And these are all the tests that need to run to validate if it is still working or not. All of them. Because any change to production is potentially breaking everything. And as you can see here, there is no manual tests here. This is just a big fallacy that you can manually test the product. And as soon as you stop thinking of this, the sooner you stop thinking of this, the better. Finally, if you pass all the tests, we release to production. In many situations, dark languages, canary releases, whatever is there. But the most important part and the most problematic part, how I see it in a lot of projects, and especially for microservices, is the test. And what I propose is running all of this, instead of running detail, just create infrastructure where it's needed, utilize it, run the test against this infrastructure, and then dispose those environments. And you can run as many of them if you want. So you can run all those things in parallel. Actually, you should be running those all in parallel. And then you can run them every time. And then actually, you will know exact amount of time it takes from you committing the code to source code repository till it appears in production if everything goes okay. There is no quick and sudden patches anywhere that you need to quickly push to production. Nothing like this. You know exactly how much time will it take. And if it consists of several components like libraries, you need to run this on every cycle. So you need to start this as soon as possible. And then we'll release it and aggregate it into one thing. But again, I'm asking to think about testing here. This is the crucial part of running and developing application scale. Again, especially for microservices application. I also like this quote. It goes like this: cease dependence on inspection to achieve quality. Eliminate the need for inspection on a mass basis by building quality into the product in the first place. Inspection is the manual testing that we're used to be doing. But it's too late. It seems safe that we can do it, but no, you just can't. You need to build the quality into your process, into the product. You need to start testing and to create feedback as soon as possible. Quickly to talk about some ideas here. Testing is not just this. The goal of testing is not to find bugs. The goal of testing is to assess the quality of the product. Finding bugs is the byproduct of this. It's just how people do it. And it's not a separate process. I still come to some teams and there is on the Jira board a special column called test or acceptance. It shouldn't be like this. It should go a lot earlier. Then it just creates a handover. My work as a developer is done, here is somebody else who tested. It doesn't build quality into the product. Also, yeah, this is another anti-pattern is that people just create more tests and then they run for 3 hours and nobody looks at that. Or half of them are sometimes red, sometimes green. Should not be doing this. Functional testing, okay, now a lot of people know already about unit tests and contract tests. But this is strange because in a lot of cases I come and talk with the QA people and then, yeah, we are creating end-to-end tests. This is enough. I don't think so. Start the testing as soon as possible. Quality goal needs to be established, needs to be supported. I believe this is a game changer. Creating automated tests is a part of a definition of done. Your story is not done until you created or updated tests. This is something that helps. And if we even go one step further, then test-driven development. You create tests even before you start implementing the feature. This is something that I've seen how it changes the mind of the team, how they look at the feature. Because, well, first of all, you're creating this idea, you're understanding the idea, when does your development ends, when the test passes. And you're starting to think through the eyes of the user, how am I sure that whatever I need to do is of a good quality, is it done? and you need to do it upfront. Still, yeah, a lot of companies think that it is hard, it's not needed, people are not prepared. I think everyone is prepared, it just needs time to be executed. Quickly about testing pyramids. Okay, now everyone knows about testing pyramid, but the aspect here is that the execution time increases when you go up and you provide more business feedback. There is no end-to-end test can show business that it's working feature, but broken unit test doesn't tell anything to business. And same applies back. Development feedback goes towards the bottom to the pyramid. But what is crucial here is feedback. So get the opportunities to create feedback, and ideal feedback comes on developer's computer. Still, it's well, something is working or something is not working. And then the feedback can be positive, can be negative, but this is how we create the processes that facilitate what is needed. And broken pipeline is the most known idea of feedback. You can't continue. It's negative, it's red, you can't. So you need to change your behavior, you need to change your tests. And as I said, testing is a shared responsibility. I believe that the best testers are software developers. Really, I've been talking about this for a number of years, and the best excuse I got is, well, there are people who build stuff and there are people who break stuff, and these are two different mentalities and they don't match. This is bullshit. How can you build something if you don't know how to break it? How are you sure that you built the right thing? And vice versa, how can you break something if you have no clue how it's built? It's not professional to even try to say it's not my job, it's somebody else's job to test. It's your job as a software developer to test your code. And you are the best person who knows how to test it, not somebody else. Now, quickly about the thing that's an important idea in the lifecycle of microservices, and it's updating microservices. In most cases, it goes with updating API contract. So I have been showing this for some time. Well, this is just generic microservice application, and we need to update the contract. So we got the contract version 1.0, then we update it to 1.1, and we run them together, clear, wait till the services switch. And then once everyone switched, we removed the old version. It seems simple, and it's a nice idea. This idea has, and many people are using it, this idea has a flaw. And the flaw is that everyone needs to update to use new version of contracts. So the best management of API versioning is not managing it, it's creating your contract only once and never changing it. Because as the result of this, okay, if it's an internal APIs, things are clear. You can go to the product owner of the teams, of the services that are consuming your API and just beg them, please switch to the new version that provides new features. And eventually they will do it. But maybe they have other priorities. Why are you forcing other teams, your consumers, to change the behavior? They already invested quite a number of time and hours and money to create things on top of it. Again, it's simpler inside the company, but if you're exposing public API, things are even worse. Nobody would like to rewrite this CLI tools, services that consume your contract. Nobody would ever want to do it. This is additional investment they need to do. Or this transition will take years, or months, okay, if you're lucky. But this is a hard process, and I see some teams are just stumbling upon it. Okay, we create the first version of API, and then when they want to update it, nobody wants to update it. And they have another feature in their mind, and they need another update of API, and then they need to run 3 versions here, 4, 5, and this quickly becomes unmanageable. At the same time, it's really hard to come up with the proper API in the first place. Yeah, it's not an easy job. But some companies manage to do it. Amazon is the famous example. EC2 API hasn't changed for almost 10 years. Still working. All the tools that are built on top of it are still working. This is the level of professionalism you need to aim for. Now, a bit about the team. So I really believe that a cross-functional team is needed to develop microservices now. And this cross-functional team is a team of software developers. These software developers can have different background, different focus. Some developers might have more knowledge with testing, and they need to teach everyone else in the team. Some developers might have more knowledge in what is called DevOps, but it really is infrastructure or automation of deployment. But this is the one team that shares the whole goal, and everyone is doing everything. It's not, well, my work is done, here's your time to do so. It shouldn't be like this. This should be truly cross-functional team. In a lot of cases, cross-functional team is just a team where different people are sitting and doing work together, but yeah, in some cases they don't communicate. But I also found this investigation about how to find the high-performing teams. And there was a quick questionnaire there that if you answer yes to those questions, it's a bigger chance that you are in a high-performing team. And I want to share this with you. So yeah, about the purpose and autonomy. The first question, it goes like this. Does the mission, purpose of my company make me feel like my work is important? In a lot of places I get the question, what is the mission and the purpose of my company? I have no idea. Does my supervisor, somebody at work, seem to care about me as a person? Do I understand how my everyday decisions help mission and purpose of my company? If you don't know the purpose of the mission, no opportunity here. Do I know what is expected of me at work? Generally, you should answer yes, but again, it's surprising, but a lot of people don't know. At work, do my opinions seem to count? Another, also, questionnaire here about the mastering. Do I have the materials and equipment I need to do my work right? It's a laptop, anything. Do I have opportunity to do what I do best every day? Does somebody care about my development? Are my coworkers committed to doing equal quality work? Yeah, I am, but those guys, no. Somebody talked in the last half year about my development? Do I have opportunities to learn and grow? These are the questions that should be answered yes, if you want to be in a good team. But the most important question, I think, out of this one is this one. Do I have the opportunity to do what I do best every day? This should be your goal, right? Come to work, kick ass, and then go and do whatever you do after work. Because people are company's best asset. Yeah, it's sometimes forgotten, and the company is everything else, but people change the company, and we as IT help business grow. They can't without us. Another quote, developing people and the system so that together they're capable of achieving successful results is the point, said by Mary and Tom Poppendick, who are mother and father of the idea of lean software development. Now, I would like to share some principles with you, and yeah, let's have a look. If you think that you don't understand something or you disagree, just raise your hand, we can discuss it. But I think we've got time. Yeah, we've got time. So the principles: eliminate waste, and I will dig deeper in each one of them. Amplify learning, and decide as late as possible, deliver as fast as possible, empower the team, build quality in, and optimize for the whole. These are the principles of lean software development. Again, lean was created as the Toyota manufacturing system long ago. So all this lean transformation happened already in manufacturing. And the strange thing is that Mary and Tom Poppendick has created this idea in 1999, I think. And this feels weird. You open the book from 2000, and you read it as a so fresh thing. The problems that were explained then are exactly the problems that we're still having in 2017. And this is a strange thing, really. These ideas still apply, and we're still doing bad job of implementing those. But what are they? Waste. What is a waste? Partially done work. This is a so common thing. Let's do more, and that thing we will finish later. And then Jira board looks with these 10 or 15 tickets that are never moved afterwards. This is a huge waste. Time was invested, people were working on this, and suddenly let's stop and do something new. Why? This aggressive and wrong mentality. Extra processes, well, this can come as a ceremonies or extra approvals that you need to take. It's all over the place, but this is something that is not needed to deliver applications to production. Extra features, something that won't be needed. Sometimes this is called bells and whistles. They are nice, but they are not needed. Task switching, this is especially cruel for software developers. Really, really cruel. I will come and ask you one quick thing for 1 minute, and then how to return back to flow. Waiting. Yeah. Motion. Motion is when you have to go somewhere to do something. Like, I don't know, a person in your team sits in another place, and in order to go to talk to him or her, you need to go through the whole office. Why not sit together? Just one of the examples. But especially defects. This is the biggest waste. And it comes in a lot of cases, something that we get used to, like, for example, creating bugs. The question always asked, why the bug is created and put in Jira instead of fixing it immediately. In most cases, if it's a bug, it's a problem, why it is not fixed immediately? Why do we need to put it in Jira, then plan it, discuss it, put it into sprint, and go through the whole overhead of administrative work to fix something that was found? Why not fix it immediately? This finding the bug provides no value to anyone. Fixing the bugs provides value. And we are postponing this to later. We shouldn't like this. Learning. This again goes through the plan, do, check, act, or through build, measure. No, learning is what needed. How do you do learning on the job? It's not only learning for the business issue, but how do you do your learning? Pair programming. This is something that, surprisingly to me, in a lot of teams is not accepted by business, but it's not accepted also by developers. I need to convince developers to try pair programming. And then this is a bit of a really intimate thing, because you need to open the way you are thinking, how you are doing stuff, how you are creating the features. But this is how learning happens. And what also goes unintuitive here, and I've seen this happening, actually 2 programmers are creating feature faster than 1. So, and sometimes it's 2 times fast. I've seen this happen, so a lot of times in your work you just stumble upon something. Oh shit, you need to fix it, and you're thinking how to overcome the problem. And if you're doing this in pair, in a lot of cases the person who you're pairing with will have a solution, will have ideas to try. Even if you're running out of ideas, there is your co-pilot to try it. And this is why the time is saved here. And in a lot of cases, a better solution is created, or better code is written, because of second pair wise. And I really promote pair programming. Again, I don't understand why, I understand why business doesn't want to do it. They think, okay, this will just deliver half of the features at the same time. Again, it's the other way around. But why developers don't like it? This is the best opportunity to learn from group guys. Code review, a bit of worse opportunity to learn, but if you have an enemy, just you can do a lot of stuff there. But if you're doing good code reviews, you can learn from your colleagues, and yeah, really needed. Documentation, nobody likes documentation. But yeah, I've changed my mind here, and I also thought documentation is not needed. This is for people who don't have time to understand how the application is working. But surprisingly, nobody has time to understand this. Really, nobody has time to invest. Either you have a clear documentation how these things are going to be used, or nobody is going to use it. Because they don't have time, they're busy doing their own work. and documentation savings. Wiki, commented code, let's not go into details, knowledge sharing session, a really important thing in your companies if you can do it. Trainings, and so on. Another idea is that it's called decide as late as possible, and it took me quite a while to grasp it, because, well, the point is that it's better to take a decision that is irreversible late in the process. The famous example that I see is that the decision on which database engine to use is done upfront. And then, whoa, we're in development, and later, oh, we should have used relational database, and it's 3 months in development. Or, oh, we should have used Cassandra, whatever. It's too late to change this. This is really expensive to change it now. And in a lot of cases, you can implement your work so that it doesn't matter which database to use. Not every time, but in a lot of cases. And this is just one of the examples. Things that are hard to change, try to decide as late as possible. Because then you will have more, you will have a lot more information. You will learn along the projects how it's working, how it should be working, and then you will make the best decision. Then it will be time. Because if you create too early, you limit your choice late. Deliver as fast as possible. Well, we talked about this continuous delivery, DevOps, Agile, shared responsibility. And again, this idea of empowering people. People in the team are the best person who know how to improve things, not the management. You are the ones who should change and improve your work. Nobody else can do it. Building quality in, I talked about this already, but this is one of the important lean principles. Here goes Anton Court stop line, mostly known as in IT, if your pipeline is broken, yeah, you have to fix it, you can't deliver something. Pair programming again, this is really what improves quality. Test-driven development, feedback, we talked about this. Minimize handovers, this is the thing that is important. If possible, one team should do feature end-to-end. Because then it's one responsibility and you can optimize the flow and implement the feature as soon as possible. If you need to implement something, then wait for another team, then wait another, or in the example, you've implemented some work and then you're waiting for QA engineer to test it manually. This all creates waiting time, and in most cases, a lot of knowledge is lost on these handovers. And they don't make sense. Continuous integration, a lot of people think they do continuous integration, they do not. But this is another big topic. Automation. And finally, optimize for the whole. This is something that if you need to optimize for the idea of delivering feature to production. This is it. And if you go to enterprise, they used to have these silos. This was the Vox movement was about to break those silos. So it was the development teams, QA teams, even not teams, departments, and then operation departments, and then there was this joke about next common manager that is generally in CEO or CTO or something like this, and this is escalation. You need to go to fix something because teams and company and silos, they optimize their own processes for their own sake, but not for delivering value. And the value in our case is the software that is working. It needs to be put into the hands of the users. So this is why the idea of continuous delivery was so important, because it focuses how you're streamlining this, how you're making this as soon as possible with feedback as much as possible. Product orientation versus project orientation. Remember at the beginning I showed you that with the project it has its ending. So you end the project and your information is gone, all the knowledge is gone. But if you're working on product, in most cases you continue developing, continue as long as this product is still on the market. And this is where the knowledge that you gain is useful to implement new features, to do it better, to come up with some ideas. But if you're working on the project, it's stopped, you're working on the next one, all the knowledge is just lost. There are some problems with Lean, and most famous one is cargo cult. We're also doing Spotify model, or something like, we're also using AWS, Cassandra, whatever. Google is doing this, we need to do this as well. Oh, Facebook is doing that, we need to do it as well. They have their own problems and they're solving their own problems. If you're using the tools that they're using, there is a big chance that you're using a tool that doesn't solve your problem. It doesn't, well, it can happen, but I see a lot of, yeah, we're doing this. Why? Because those guys are doing this. LinkedIn is using Cassandra. We're using it as well. This is needed for you? Maybe MySQL will be okay. No, this is so cool. Or Lambdas. Yeah, everyone is talking about serverless now. We just must do it. Yes, everyone's doing this. Why? Does it provide any value? Focus on tools. This is the very same thing. We will start using this tool and our life will change. It will not. We will start doing this because we're using the tool, everything will be better. It will be not. Because you're just trying to use the tool to improve something, but you don't understand what you're trying to improve and why are you doing this. And yeah, this is what I was talking about, deciding the solution without understanding the problem. It's just famous. So yeah, these principles. And towards the end, some time ago I found this picture. It's possible modern agile, but you can put here, development of microservices, modern application development, whatever. I won't go into details, but look at the 4 areas actually that are here. Deliver value continuously. This is what we were talking about. This is what is needed. You need to constantly deliver something to them. Experiment and learn rapidly. You can't find out what the users need without experimenting and learning from them. And you can't find out without making the users awesome. If you're not focusing on the user, who are you focusing on? And making safety a prerequisite, because if people start experimenting, if people start taking responsibility, they will fail. This is how we learn. And then it needs to be done correctly. Not, oh, you failed, now, yeah, and everyone knows this. This needs to be treated correctly. Pity enough in a lot of companies, this is the biggest circle. This is where things go wrong. Really pity. Because, yeah, we have one common goal with everyone. Development, product owners, stakeholders, we are all working together to make businesses succeed because it pays our salaries, but it also gives the good feeling that we are doing something that people are using. And this is, I believe, is the best feeling that you can get. This is it. Thank you, guys.
I remember.
I have a question. Although it wasn't directed to microservices architecture, stuff like that, I saw you pointed out a lot of lean principles. Would you say lean is more adequate for microservices architectures and building stuff than Scrum?
Is Lean more suited to building microservices than Scrum?
Organized behavior that build microservices.
So to me, it's not one or another. Scrum is more how you organize the process of software development. Lean is more ideas that you put in place. And I believe those are very important. And the biggest challenge when transitioning to microservices is doing the same but at a bigger scale. Now you had one monolithic application, you had one process, suddenly you start breaking it or developing microservices and you have 10, 20, 100 processes. If you don't have maturity of the process with all the automation, if you don't put the ideas of improvements, it will become really hard to manage this. Or you will do these aggregated releases, you will still try to deploy to other development environments, try to stabilize the product, but this is not how software is developed now. I don't think that this is the best way. So this is why Lean is something you put on top of it. This is the ideas, how you look at development, how you look at the processes to improve them.
Other question? I learned the Romanian word, provocator.
I really like it. I want to challenge you a bit on the teams. When you were talking about the team,
Yep.
and the big message was that every day you should do something you're good at. At the same time, when you look at the cross-functional team, that everyone should be able to do kind of everything, which means that for sure you do something you're probably not good at or don't like. How this comes together?
So how we align doing the best you can with doing something you
With
don't
doing
something
everything
you
you
don't
should
like.
do.
Well, you can do something you don't like and do best of it. Really. To me, it is the story of software developers creating the tests. It is known, everyone hates this, but software developers create best tests. This is what I found out. If we need to automate infrastructure deployment, software developers do it a lot better than DevOps engineers. It's a pity to say that, but this is what I see. And then, yeah, you see feedback, we don't want to do it, we don't like it, but when people start doing this, they're doing really the best they can, and you need to look with this programming mindset. But yeah, then the problems are solved differently than manually or anyhow others. But I believe that there is no conflict here. You can do the best you can even if you don't necessarily like what you're doing. But if not you doing the test, who else? If not you are doing it. No, my point is that if it is a cross-functional team with a shared responsibility, there is no function of QA engineer, this is just a hat that you put on yourself. If you're refusing to do that, who will do it? Somebody else in your team? Why? This question, why he or she will do it if not you? So I believe there is no conflict.
I have one. When exactly do you think monitoring should be implemented in the product lifecycle?
As soon as possible. So to me, it's the part of definition of done for any feature. You need to start with monitoring, because this is how you learn. This is the only way for you to find out how your application is running in production, but more importantly, how users are consuming your applications in production. Otherwise, you're blind, or you have an operations team who is doing this and checking CPUs and disk space, but you have no insights about how your application is used.
So this is what provisioning also comes first.
The question is, do we need to do automated provisioning? Or?
Yeah, provisioning. You start provisioning.
Everything needs to be easy and available for everyone.
With the feedback options.
Yeah, correct. Some people don't even run the testing, they test in production. And it's working for them because they have, it's in the department, but they have an opportunity to create a rollback, identify the issues, and then testing before that is not needed. But this is, again, another topic.
Questions?
Now, I want you to give a big round of applause to previous speakers that are standing there, because their talk was great. And a big round of applause for Michaela, who were hosting this meetup and doing everything. So